Okay, in the last class, we talked about the first type of externality, the negative reduction externality. For example, the factories generate pollution. And in this class, we will talk about the second type of externality, the negative consumption externality. For example, the second-hand smoke affects others, but this influence occurs among consumers, so it is not a negative production externality, but belongs to the negative consumption externality. So this is what we will talk about this day. First, we draw a coordinate system. The y-axis is the price, the x-axis is the quantity. Right? Just like in the last class, we can also draw a supply curve, it's like this, and a demand curve, it's like this. Okay, now let's analyze whether the externality affects the supply curve or the demand curve. This is the two curve that is considered without externality. Now we need to consider the externality. Okay, we know that it is a consumption externality. The consumption externality is for the consumers, right? The consumers. And we talked about before, the supply curve is about the behavior, about the suppliers, and the demand curve is about the behavior, about the consumers. So the consumption externality must affect this one, right? So we need to determine next whether it affects shift upwards or shift downwards. Since it is a negative externality, it's a bad effect. There must be some damage, so we need to draw a curve that is called marginal damage. Just like we talked about in the last class, the marginal damage is a line slopes upward from the origin. It's like this. Okay? It's like there is a factory. The factory is polluting the air, and the PM 2.5 of this city rise from 0 to 100, and it's continue polluting the air, and the city PM 2.5 rise from 100 to 200. It seems that the amount of pollution in these two processes is the same, but actually the later one has a greater impact on people, right? So that is the reason why the marginal damage is getting larger and larger when the quantity increase. So why is called marginal for marginal damage? It is the impact of the damage on people for each additional unit of quantity. So the marginal damage is getting larger and larger. Okay, that's the reason why the MD curve is like this. If we don't consider the externality, we know that the demand curve is MPB or MSB. But if we consider the externality now, it means that this MD affects the MSB, because the MSB is considered the whole society. So if we consider the externality now, the MSB will deviate from this D curve and it will decrease. Because the MSB is related to the society, it takes the whole society into account. Since the MSB needs to consider the whole society, we also know that the MSB is equal to the MPB minus MD. So we know how to draw the MPB, we know how to draw the MD, we also know how to draw the MSB. Right? That is to say the distance of MD from the x-axis is equivalent to how much the MSB will decrease from MPB. Right? I will say it again. The distance of MD from the x-axis is equivalent to how much the MSB will decrease from MPB. So that is to say this line is equal to this line. This line is equal to this line. Okay, let's see how much the consumer surplus at the Q star level, as we talked about in here. If you don't understand, you can take a look at these slides. So at Q star level, the consumer surplus, you need to consider the right hand side of the Q star. The consumer surplus is this trapezoid, and the producer surplus is this triangle. And the total external cost to the society, or we said the total damage, is this triangle. Okay, the total surplus is this one plus this one minus this one. At the former slides, we have said that the total surplus is equal to the consumer surplus and the producer surplus. But at this example, we need to consider the externality. We need to consider the whole society. So we need to minus this one. We need to minus the total damage, right? So the total surplus is equal to this one, add this one, minus this one. So we see the graph is like this trapezoid minus this triangle. And as we said before, this line segment is equal to this line segment. So we can know that this triangle is equal to this triangle. So these two triangles have the same base, they have the same height, so they have the same area. So our equation is equal to this trapezoid minus this triangle, right? So it's finally the outcome is this triangle. The A is star B. Okay, this is our final outcome. Okay, at Q1 level is very easy. At Q1 level, the consumer surplus is this triangle, and the producer surplus is this triangle, and the total external cost to the society is this triangle. So the total surplus is equal to this one plus this one minus this one. So it's equal to this big triangle minus this triangle. And as we said before, this line segment is equal to this line segment. So this triangle is equal to this triangle because they have the same base, they have the same height. So our outcome is this big triangle minus this small triangle. Okay, so the final outcome is this one minus this one. Okay, we finally calculate the total surplus, the TS star and the TS1, and we need to compare the difference between the TS star and TS1. So we need to use the TS star minus TS1. We can eliminate this two, so the final outcome is E star E1F. In the graph is this triangle. So this triangle is the deadweight loss at Q1 level. So the area of this deadweight loss is what we want to calculate, the inefficiency of outcomes with a negative consumption externality. Okay, this is the second type of externalities. Then let's look at the third type of externalities. It's called positive production externality. And this one is different from the former two because it is a positive externality, because it's a good impact on the whole society. So we can't use the MD curve because MD curve means there is some damage, right? We can't use the marginal damage curve. We can change it to the MEB curve. But the MEB curve is different from the MD curve. Do you remember the MD curve is from this origin point and becomes larger and larger, and the MEB curve is starting from this point and become smaller and smaller as the quantity increase. It means that as the output or as the quantity per unit increase, the benefit brought about will gradually decrease, because we can understand in this way in a society or in a city or in a country. Let's assume that everyone, for example, this is every citizen, everyone has not received an education. However, suddenly one person gets educated. The impact of this person brings to the society is extremely significant. But as the number of educated people becomes increasing, for example, everyone in the society except one person, everyone except this person gets received education, then if I educate this remaining person now, will the benefits he brings to the society increase? It will be very small, right? Because almost everyone educated. So that's the reason why the MEB curve is from this starting point is at a very high level and gradually decrease. After knowing the MEB curve is like this, we need to determine whether it is impact on the supply curve or its impact on the demand curve. So the supply curve is like this, the demand curve is like this, is very similar as before. So the MAB curve impacts this one or impact this one. We need to use these words. It's the production externality. We said the production is for the suppliers, right? It's for the suppliers, and the supply curve is for the suppliers, and the demand curve is for the consumers. So this kind of externality must impact this curve, must impact the supply curve. So next we need to determine whether is the supply curve increase or the supply curve decrease. If we didn't consider the externality, the supply curve is MPC or MSC. But now we need to consider the externality, and the C means the cost. Cost is the money. So if there is some benefits, our cost will decrease, right? So the MPC curve will decrease to this line. This new supply curve is called MSC. We need to know that these two lines are not parallel, because the MSC is equal to MPC minus MEB. But MEB is not a constant number, it's not invariable. So we can see that when the Q is equal to 0, the MEB is the largest. So when the Q is equal to 0, the MSC and MPC, their difference is the largest. If I extend this line, you can understand. You see, the MPC curve and the MSC curve their difference is the largest. As the quantity increase, their difference becomes smaller and smaller because the MEB curve becomes smaller and smaller. Right? S curve and the D curve, their intersection is the equilibrium point. So this is the former equilibrium point. This is the new equilibrium point. So at the Q star level, the consumer surplus is this triangle, and the producer surplus is this triangle minus this triangle. If you don't understand, you can take a look at these two graphs. You can know this. And the total external benefit to the society is this trapezoid. So after knowing the consumer surplus, the producer surplus, and total external benefit to the society, we can add them together. Some student may ask why it's not minus this one. Because it's the benefit to the society, it's a good impact. So our total surplus should add this one instead of minus this one. Okay, so the total surplus is this one plus this one plus this one. This triangle plus this triangle minus this triangle, and plus this trapezoid. And at Q1 level, the consumer surplus is this triangle and producer surplus is this triangle. Total external benefit to the society is this trapezoid. Okay, we can add them together is this big triangle plus this trapezoid. Okay, if we want to calculate the difference between the TS star and TS1, we just need to use this one minus this one. So first we can simplify these three terms into these two terms, and simplify these two terms into this one term. And remove the brackets, we can eliminate these two, and we use this one minus this one. We get another trapezoid, is GHQ star Q1, GHQ star Q1. So we can change the GHQ star Q1 into E1D E star F, because these two trapezoids, they have the same upper base, they have the same bottom base, and they have the same height, so they have the same area. So this one minus this one is equal to this one minus this one. So finally we got that we lost is E1 E star F. Okay, so E1 E star F is the inefficiency of outcomes with a positive production externality. So we finished the third types of externalities. Let's move on to the last one, the positive consumption externality. As we said before, the y-axis is the price, the x-axis is the quantity, and this is the supply curve, this is the demand curve. We need to know the externality impacts which curve, is the supply curve or the demand curve, because it is a consumption externality, is a behavior about consumer, right? it is a behavior by consumers, so it must impact the demand curve, because the demand curve is for consumers, the supply curve is for the suppliers, or we said the firms. So now we need to determine whether the demand curve will shift upward or shift downward. Because it is a positive externality, so we don't need to use the MD curve. We should use the marginal external benefits curve, MEB curve. So this is MEB curve. As we said before, is from this point, the starting point, and decreasing, right? And the MEB curve is a good thing, so it must rise the benefits. So the MSB curve must detaches from the MPB curve. It will rise from this curve to this curve. We need to know the difference between these two curves is equal to MEB, because MSB is equal to MPB plus MEB, right? So we can see that these two curves are not parallel, because when the Q is equal to 0, the MEB curve is the largest. So when the Q is equal to 0, the MSB and the MPB curve, this distance is the largest, and it becomes smaller and smaller when the Q increase. Okay, after knowing this, we can know the intersection of the supply curve and demand curve. This is the former equilibrium point, this is the new equilibrium point. And let's calculate the consumer surplus, the producer surplus, the total external benefit to the society, and the total surplus. So firstly, we calculate at Q star level. At Q star level, we don't need to consider the right-hand side of Q star level. So the consumer surplus is this one minus this one. Okay. If you don't understand, you can take a look at this slice. Okay. And the producer surplus is this big triangle. And the total external benefit to the society is this big trapezoid. Okay, the total surplus is this one plus this one plus this one. And at Q1 level, we don't need to consider the right-hand side of the Q1 level. And the consumer surplus is this triangle, and producer surplus is this triangle. And the total external benefit to the society is this small trapezoid. Okay, so the total surplus at Q1 is this one plus this one plus this one. So after knowing this, we need to calculate the difference between this one and this one. We use the TS star minus TS1. First, we remove the brackets and we can eliminate these two. And we can use this trapezoid minus this trapezoid is equal to GHQ star Q1. And GHQ star Q1 is equal to DE star FE1, because these two trapezoids, they have the same upper base, they have the same lower base, and they have the same height. So this one is equal to this one. We use this one minus this one is equal to DE star E1. DE star E1. So this triangle is the deadweight loss at Q1. And this is what we want to calculate the inefficiency of outcomes with a positive consumption externality. Okay, now we turn to the externality solutions. To solve the externality problem, we have private solutions and government solutions. Let's look at them one by one. The first situation is called the private bargaining. So let's consider two extreme situations. The first extreme situation is to assume that everyone has the right to enjoy a clean environment. That means that if any party in the society causes some damage to the society, such as the pollution, it has to take initiative to deal with this pollution. If it doesn't deal with this pollution, it needs to consider giving some compensation to the affected parties. Let's assume that there is a factory in a society and it's causing some pollution. And now it has two options. The first option is that it takes the initiative to reduce pollution, which may cost it 500 Hong Kong dollars. It may need to introduce some new equipment or use some new energy materials, all of which require spending money, right? So it also has another option, that is continue polluting. But this pollution will cause loss of 300 Hong Kong dollars to others. That means others may need to spend 300 Hong Kong dollars on treating their diseases, but if it continues to pollute, it needs to give some compensation to others that they will keep quiet. Now let's figure out how much the compensation should be between. It should be between 300 and 500. Let's think about it. If the compensation is more than 500, for example, if the compensation is 600, then it's better for the factory to directly reduce the pollution, right? Because directly reduce the pollution only need to spend 500 Hong Kong dollars. But if gives the compensation, it has to spend 600 Hong Kong dollars. So it's not worth doing it. Okay, if the compensation is less than 300 Hong Kong dollars, for example, 200 Hong Kong dollars, the affected parties will not willing to accept it because they need to go to the hospitals or do something. It will cost them 300 Hong Kong dollars, but the compensation only 200 Hong Kong dollars. So they were not willing to accept it. That is the reason why the compensation should be between 300 Hong Kong dollars and 500 Hong Kong dollars. Let's move on to the next assumption. The second extreme situation is that everyone has no right to a clean environment. In this case, for example, if the government doesn't formulate some policies about the environmental protection, then does the factory still need to be responsible for its pollution? There is no need, right? Instead, the affected party should give the factory some money, or we said bribes, to make the factory stop polluting, right? So now the factory is faced with two choices. The first choice is to accept the bribe and reduce the pollution. So the cost of reducing pollution will cost 400 Hong Kong dollars. It may be to introduce some new equipment or some new energy resources. The second choice is to continue polluting and not accept the bribe from others. But the continue pollute will cause a total loss of 600 Hong Kong dollars to the society. So now we need to calculate how much the bribes should be set, that both parties can accept it. The final result calculate should be that the bribe should be between 400 Hong Kong dollars and 600 Hong Kong dollars. Why? We can imagine that if the bribes is like 700 Hong Kong dollars, the affected party will think it is not cost effective, because the affected party thinks that if you continue to pollute, it will only cost a loss of 600 Hong Kong dollars to me. But if you don't pollute, I still have to give you 700 Hong Kong dollars. Then I'm not cost effective, right? I even lost 100 Hong Kong dollars. And if the bribe is less than 400 Hong Kong dollars, for example, 300 Hong Kong dollars, the factory will think it is not cost effective. The factory thinks that I accept your 300 Hong Kong dollars, I still have to take the initiatives to spend 400 Hong Kong dollars to reduce the pollution. Then I also lose 100 Hong Kong dollars, right? So the bribe is finally calculated should be between 400 Hong Kong dollars and 600 Hong Kong dollars. That is between the cost of pollution and the cost of reducing pollution. So these two extreme examples can reflect the Coase theorem. So the Coase theorem is that when the cost of bargaining is almost zero or very low, the allocation of resources is not affected by the initial distribution of property rights. That is to say, the two parties can successfully negotiate. Then the Coase theorem has two assumptions. The first one is the cost to the parties of bargaining are very low. So what does it mean that bargaining costs is very low? It means the monies or the human resources spent by the two parties to reach an agreement are very little. For example, negotiating the price and setting the some laws, the regulations. These processes are very smooth. There is no need to hire a lawyer or conduct a research. So in this way, the two parties can easily negotiate according to their respective interests and needs. Then the effective allocation of resources by the market mechanism mentioned in the cost theorem can be achieved. If the bargaining cost is very high, it may hinder the transaction and it may not be possible to achieve the optimal allocation. Okay, the second assumption, you can see that the resources owners can identify the source of damage to their property and enforce the bargaining results. Means that the affected party knows that he had to spend this like 600 Hong Kong dollars on getting sick or spending on the hospitals. Then he knows that his illness caused by pollution, so he will go to the factory to negotiate, to bargaining. Well, these are two basic assumptions of cost theorem. Let's take a look at the second method, which is called merger. So why can mergers solve the problem of externalities? For example, factory A is polluting the environment, and its negative externality has an impact on factory B. Then what if factory A directly acquires factory B? If two of them merge into a new firm, their externality can be internalized. So this is a relatively direct way to solve the problem of externalities. The third method is called social conventions. For example, in a society or a community, everyone agrees to take good care of the public environment. Then such a convention will make residents reduce their behavior of littering. So this is actually a way to solve the externalities without the intervention of the government. There is another example. In recent years, many companies have the concept of environmental responsibility. They believe that if they perform well in environmental protection, they will attract more investors. Perhaps the investors think that this company has done a good job in terms of the social conventions, so I can continue to trust it and think it has prospects. Therefore, more investors will invest in their company. This is also an example of social conventions solving externalities. Okay, let's take a look at some of the methods for the government to solve the problem. The first method is to levy taxes. Suppose there are two firms in the market. Firm A has pollution and firm B does a very good job, it has no pollution. Then if I were the government, I want to deal with this imbalance problem, I need to impose a pollution tax on firm A. So if firm A is required to pay the pollution tax, at this time the company A needs to think, is it better for me to pay the tax and continue to pollute, or is it better for me to take the initiative to deal with my pollution and not pay the tax? But this method has a limitation. What is the limitation? Let's recall our first graph. The negative production externality. We used the example of factory pollution. Do you remember it? So as the government, if I levy a tax, what is my purpose? My purpose is to make the Dawei loss. It makes this small triangle equals to 0. Then I need to calculate how much my supply curve needs to rise. If my supply curve rises to here, it has intersection with E star, then my Dawei loss is equal to 0. It's the best situation. So as the government, I need to draw this whole graph to determine my tax amount. At this time, the information requirement is very high. Okay. Let's continue to look at the second method. The second method is the subsidies. A subsidy is very similar to the tax. We said that the tax is levied on the company A. If it is a subsidy, we don't punish any party. Instead, we directly give some subsidies, give some money or other things to the company that has done a very good job. Then when the company A sees that company B has received a subsidy, company A also need to weigh up. Should I deal with my pollution and get this subsidy, or should I continue to pollute and not receive any subsidy? This is also a method for the government to solve the externalities. Okay. The third method for the government is to create a market by issuing permits. What does it mean? That is to say, for example, as a government, there are two companies in the market, company A and company B. So as the government, I can give 500 permits to factory A, and for the sake of fairness, I can also give 500 permits to the factory B. That means factory A, you can discharge 5 tons of pollution, and I won't punish you. And for factory B, you can also discharge 500 tons of pollution, and I won't punish you either. However, if the company A wants to expand its production, the factory A wants to discharge 1,000 tons of pollution, the factory has two options. The first option is that it discharges 500 tons and treats the remaining 500 tons by itself. And the second option is that it directly buys 500 permits from the factory B. So if I give these 5 permits to factory A, I will have 1,000 permits, and it can discharge all the pollution without having to treat it by itself, right? So let's look at this example. Suppose the factory A has 500 permits. If it doesn't use the permits and treats the pollution by itself, it will cost $1 per ton. And if the factory B also initially has 500 permits, and if the factory B doesn't use the permits but choose to treat the pollution by itself, it will cost $0.5 to discharge 1 ton of pollution. So at this time, if factory A wants to expand its production, it can buy permits from factory B, right? So how much is factory A willing to pay? It is willing to pay a price less than $1 to buy the permits from factory B. Why? Because if it doesn't buy, it needs to spend $1 to treat the pollution by itself, and it thinks it's not cost effective. If it can buy from factory B at a price less than $1, it doesn't need to treat the pollution by itself. So factory A is willing to offer a price less than $1 to buy from factory B. Then how much is factory B willing to accept? The factory B is willing to accept a price is greater than $0.5 because the cost for factory B is to treat the pollution is very low. Factory B only needs to spend $0.5 to treat the pollution by itself. It thinks, well, if I treat by myself and then sell the permits at, for example, $0.7, I can still earn $0.2, right? So the trading price should be greater than $0.5 and less than $1. Okay, we can calculate with a specific number. Suppose there is no transaction between factory A and factory B. The factory A needs to expand its production scale. The factory A wants to discharge 1,000 tons of pollution, but factory A only has 500 permits that allows it to discharge pollution. Then it needs to treat the remaining 500 tons of pollution by itself. How much does it cost? It needs to spend 500 multiplied by $1 because the cost for it to treat the pollution is $1 per ton. So it's 1 times 500 is equal to $500. The factory A needs to spend $500. The factory A needs to spend $500 to treat the pollution by itself. Okay, then assume that there is a transaction between factory A and factory B. For example, the trading price is $0.7. That is equivalent to factory A needing to buy 500 permits from factory B. Then the factory B needs to treat its 500 tons of pollutants by itself, how much does factory B needs to spend? Since the factory B has sold the permits to the factory A, the factory B has to treat its pollutants by itself. It needs to spend 0.5 times 500 is equal to $250 to treat its own pollutants. So how much does the factory A needs to pay it? That is to say, how much can factory B earn? The factory B can earn 0.7 times 500 is equal to $350. That is, factory B can get $350, but it still needs to spend $250 by itself. So the factory B can earn more $100. Okay, then how much does the factory A earn? The factory A actually saves $500 minus $350. It can save $150. Okay, this is the third way for the government to solve the problem of externality. Let's look at the next solution. Direct regulation. Direct regulation means that the government gives each firms a clear indicator. For example, the government requires the factory A that you can only discharge 500 units of pollutants, and the factory B, you can only discharge 500 pollutants. That is to say, the transactions between them are not allowed, and this is no market between them at all. So these two methods are actually very similar. The direct regulation and issuing permits are both about stipulating the quantity of pollutants, but the difference is that the later one, there is no market between the factories, but the former one, issuing permits, there is some transaction market between them. Okay. So many economists believe that the direct regulation is a very inefficient solution to address the externality. Okay, that's all for our lecture 2.